Yeah, student, we have another question of the laws of motion that has been asked in JE Advance, or we can say IIT JE in 2009, because at that time there were no any case of the JE Advance. At that time, basically exam were by the name of IIT JE or simple IIT. So this question has been asked in 2009. Let's say what the question is saying. Question is saying like a piece of wire is bent in the shape of a parabola y is equal to kx square. That means we have a piece of wire that is in the form of parabola. We have a piece of wire that is in the form of parabola like this. Okay, like this. Okay, and here y-axis is vertical line. That means let's say this is the y-axis and this is the x-axis. Okay, and there is a bead of mass small m on it. There is a bead of mass small m on it. Let's say this is the bead of mass small m. Okay, the bead can slide on the wire without friction. Here the question is saying that there is no friction is working on the bead. It means when we will leave this wire stationary, and if there is no any acceleration in this wire, then this bead will must be at a stable equilibrium at the lowest point. When we will leave this wire, and if there is no any acceleration in this wire, then this bead will be at a stable equilibrium when it will be on the lowest point of the wire. Okay, now the question is saying it stays at the lowest point of the parabola when the wire is at rest. As we can easily understand, if wire is at rest or if wire have no any acceleration, then this bead will be at the lowest point at the equilibrium. Okay, now question is saying the wire is now accelerated parallel to the x-axis with a constant acceleration a. That means this wire has been given a constant acceleration a parallel to the x-axis. Constant acceleration a parallel to the x-axis. The distance of the new equilibrium position of the bed. Now question is asking what will be the new equilibrium position of the bed as the wire have the acceleration. So obviously this bead will experience a pseudo force, and now when it will experience a pseudo force, this will not be its equilibrium position obviously. So question is asking what will be the new position of the bed at rest, where the bed can stay at rest with respect to the wire from the y-axis. Question is asking what will be the distance from y-axis, not from the x-axis. So let's say when wire will move towards x-axis with acceleration a, and let's say its new equilibrium position will be here. Let's say the new equilibrium position will be at this point. So we have to calculate the value of x. That means distance from y-axis. Distance from y-axis, that means this value we have to calculate. Okay, so how we can calculate this question, how we can calculate this value? Let's see. Here when we'll see this bead, we will draw its free body diagram initially, and the free body diagram will be like that. Here will be the normal force, here will be the normal force, and let's say there will have two component along this and along this. Okay, and let's say from vertical this angle is theta, so this angle will be 90 minus theta. We can say the component will be n cos theta upward and n sin theta along positive x-axis, n sin theta along positive x-axis. Also the wire is accelerated, so it will experience a pseudo force just opposite to the acceleration. That means along negative x-axis there is a pseudo force ma, and as well as there is also downward force, that is mg. Okay, now we can easily say that what we can easily say this n sin theta rightward force will be equal to ma, because at this point the wire is at equilibrium, wire is at rest. So we can say n sin theta will be equal to ma, and n cos theta will be equal to mg, and by dividing these two equations we will get tan theta is equal to a by g. This is our equation first. Okay, now we can easily draw a triangle here like that. Sorry, we should change the color. We can draw a triangle here like this. Okay, and as we move this hypotenuse like this, so we will get this angle is theta, so we will get this angle will be 90 minus theta, and this angle will be theta. As this angle will be theta, so we can say this angle will be also theta, because this is alternate interior angle. These two lines are parallel and this angle is theta, so we can say this will be also theta. Okay, and let's say this length is dy and this length is, let's say, dx. So we can say what? We can say, as you can see easily, this triangle, when you will see this triangle, you will find like this. Okay, this diagram is like this. This diagram is like this. This angle is theta, and this is dy, and this is dx. Okay, so we can say what? We can say tan theta will be equal to dy upon dx, or we can say this will be d by dx. And here the question is saying that the equation of the parabola is y is equal to kx square. According to the question, y is equal to what? Y is equal to kx square. So we can put here at the value of y, we can put y is equal to kx square at this point. So this will be what? This will be k will be taken out, and this will be dx square upon dx, and by differentiating this we will get 2kx. We will get tan theta is equal to 2kx. This is our equation 2. And by using these two equation 1 and equation 2, we can say what? We can say a by g is equal to 2kx, or we can say a by 2kg is equal to x, or we can say x is equal to a by 2kg बोले और या g के बोले, है ना? तो so our answer x is equal to a by 2gk, that will be B option. Okay, so option B will be correct, and this is very simple and very basic conceptual based question, and we can easily solve this question by using free body diagram, or the concept by applying the concept of pseudo force. Okay, and our option B will be correct here. Okay, thank you so much.